I'm really just covering one new type of problem in this lesson, and that's the derivative of an expression that is a variable raised to a variable power. And I want to do a quick review of some things that you guys already know how to take the derivative of. So first of all, we certainly know how to take the derivative of a variable raised to a constant power. The derivative of x squared is 2x. The derivative of x to the 15th power is 15x to the 14th power. Right? I mean, even if we have a weird power, even if you've got something like x to the square root of 3 power, this is still a variable raised to a constant power. And so the rule is the power rule. We bring the power down, and we reduce the power by 1. So even if that reduction of the power is a weird thing, that's what we do. If you have a variable raised to a constant power, you use the power rule, right? After that, just a couple days ago, we learned about how to take the derivative of a constant raised to a variable power. We learned that the derivative of 3 to the x is the natural log of 3, the natural log of the base, times 3 to the x. Right? And again, same deal. If we have the derivative of 17 to the x, it's a constant to a variable power, so it's the natural log of the base times the base to the power. And of course, the chain rule still applies. All of those things still apply here. What I'm covering today is more complicated. What I want to talk about today is how do we do the derivative of something like x to the x power. Note, I can't use the power rule because the power isn't constant. And I can't use the the natural log rule, the constant base rule, because the base isn't a constant. This is a really, really complicated thing. What we're going to use is we're going to use logarithmic differentiation to do this. And the way the logarithmic differentiation works is we rethink the problem. We say, all right, let's let y equal x to the x power, and say I want to find dy dx. Because really that's what this means. This problem is saying find the derivative of x to the x. And I'm saying, cool, let it be called y. I want to find the derivative of y. Now the deal is, I don't know how to take this derivative. So I will take the natural log of both sides. Right? Remember, logarithmic differentiation is the process that says, take the log of both sides. It'll probably make your life easier. When I do that, this is going to enable me to bring this exponent down. And the reason that's such great news is that now this problem just requires a product rule. Right? But the price that we have to pay is that I have to take the derivative of both sides. Note, I haven't actually done any calculus yet. I haven't taken this derivative. So now I'm going to take the derivative. The derivative of natural log y is 1 over y dy dx. And note, that dy dx, that's actually what I'm trying to solve for. That right there is the problem. That's the thing I'm trying to find. The derivative on the right side is the product rule. The derivative of x is 1. I'll leave the natural log of x alone. Plus, this time I'll leave the x alone, and I'll do the derivative of natural log. That's 1 over x. And so now I have 1 over y dy dx is ln x plus 1. And now I'm basically 2 steps away from being done with this problem. If I want to solve for dy dx, I need to multiply this thing to the other side. So I'll multiply that y over and get dy dx is y times the natural log of x plus 1. And the final step is for us to recall, hey, I know what y is. From the beginning of this problem, we said that y was going to be x to the x power. So now that I'm at this point, I can say that dy dx is x to the x power times the natural log of x plus 1. And that's the end. That's like, yay, we solved the problem. I just realized that in the interest of being proper all the way through this thing, oh, no, never mind, I take it back. The thing that I was thinking was, oh, do we need an absolute value on this x? And the reality is, because we had that, it's not something we got from an integral, sorry. So that's fine. The only time that shows up is when you're taking the integral of 1 over x, which we didn't do. So yay, we finished that example. I do have one more example, one that's a little bit more complicated. Not a whole lot. It's going to be exactly the same steps. It's just not going to be x and x. We can put more complicated things in those places. So I'll go to the next slide for that problem. Okay. So in this case, I want to say, g of x is x to the sine x power. Find g prime of x. So if you feel comfortable with this at home, pause the video, try this one on your own. It's going to be exactly the same steps as the previous problem. If you need to, watch the first step or two of this one, and then you should take over. But make sure you're getting a chance to practice this. So the first thing I'm going to do is I'm going to rewrite this as y equals x to the sine x, just because I don't want to deal with putting the natural log of g of x. I think it'll look a little bit awkward, so I'm going to write y instead. Now I'll take the natural log, ln y equals ln of x to the sine x power. Now again, if you haven't paused the video yet, pause it here, see if you can finish it from here. I'm not ready to take the derivative yet, because I need to get rid of the power over on the right. So I'll bring down the sine x, and now I have sine x times natural log x. Now I'm ready to take the derivative. On the left-hand side, I'll have 1 over y dy dx. On the right-hand side, I'm going to need a product rule. This will be cosine x times ln x plus, and it's effectively going to be sine x over x. It'll be sine x times 1 over x, but I'm just going to put that x on the bottom. My last step is to multiply that y over. dy dx is y times all of this. And I suppose at this point it's appropriate for me to say, these derivatives aren't pretty. What's important is that we can do it. The problem that was initially stated, finding the derivative of x to the sine x, previously would have been impossible, but we can do it. So we plug that y back in here, right? This thing is going to be x to the sine x times cosine x times ln x plus sine x over x. And that looks good to me. Like if we're at this point, we're in good shape. We've done the derivative. That's actually all I have to say in this video. In terms of the new problems tonight, there are only five examples of these new problems, I think, in tonight's assignment. So good luck on that, and I'll see you in class.